In this video, I'm going to take some like fake data that I generated in Excel and use a lot of statistical functions and some statistical plots that Excel has available. So if you want this data, can be found at the URL there. This is an underscore right there. You can see here's the data, and it has two sets of data, fake temperatures, fake IQs. I'll work with the temperature data. Everything can be done with the IQ data as well. So I'm going to generate, let's say, the mean, the median, find the maximum of the data, the minimum of the data, the first quartile, a third quartile. What else? Standard deviation. I'll look for the second largest, the second smallest, the kurtosis of the distribution, the skewness of the So this is a bunch of individual functions. I'll do something called the interquartile range. I'll call it just IQR. Let's spell it out for fun. Interquartile range. And then that can be used to figure out if there are we'll call outliers. So let's say there's an upper outlier bound and a lower outlier bound or something. And then I'll just put here to remind myself, I'd like to make a histogram. I'd like to make a Box-and-Whiskers plot. And then I'd also like to show the add-in, perhaps see how long this is going to take me. Okay. So the mean is in Excel, the average, it's spelled out. So I'm going to form a function, average. Just need to spell it right, average. There it is popping up. And then I'm going to go through all the data. So how much data do I have? Probably about 200 pieces of data, looks like. And there I've calculated. Now I am going to just play a trick for myself. A lot of these functions are going to be based on the same range of data. And what I'm going to do is I'm going to copy down this average formula. And I want the range to stay the same. So I'm going to put in $signs. And then I'm going to do something odd that I'm going to change the name of the function, but I'm going to sort of copy this down, just kind of a trick, a cheat. Okay, so now I have just the same function with the same data over and over again. So that doesn't seem very useful. But now I'm going to go in and change the names of the function, but I don't have to keep redoing the data range, because it's for all of them, it's the same data range. So the median is just spelled out the median. And the maximum is max. So for average, it's not AVE, it's spelled out all the way, but for maximum, it's cut at max. So you just have to, Excel gives you things sort of pop up as you're typing. So there's the minimum. And now I want the quartile. There is this, very fancy distinction between the exclusive, the inclusive. The quartile is the old one before they made these distinctions. So I'll do, I think, let me try the exclusive one and see what I get. And then you have to say which quartile you want. So I want the first. Okay. And then I will copy that down here and get the third. And now let's do the following. Let's just do quartile, the old one. And go through the whole business. And get number 1. And there might be a number of that value might have occurred a number of times. So that's not a real test on whether this was. Let me do one more and see if the inclusive is different. There's a slight change in the definition about what all is included in the range. And these come up, like if you're really in statistics, you know, these differences matter to you. And in this case, they were all the same. So this data, these were all the same, but it can turn out to be different. Okay. Anyway, let's move on from there. Next, I want the standard deviation. So that's the STDEV. And then again, it's this idea that there are 2 of them. I'm going to say I want the sample. So there's a population and a sample. And one is if this were sort of all the possible temperatures there would be for, you know, I know that this is all the data there is, then I can choose the population. Or if I think it is a sample of the possible values, then I use the sample. So I'll say it's a sample. And that's a measure of how spread out the data is. So these temperatures are not that spread out, only a few degrees. So this is a measure of spread. The mean and the median, those were measures of centrality, the sort of middle, and they're close. So sometimes, you know, which one you choose to represent your the center of your distribution can depend, but in this case they were close. So they're both good indicators of the center of this distribution of temperatures. Okay, so now we want we found it with the max, the largest, but there is a large, and then you say which one you want. So I want, in this case, the second largest. So the largest was 101.7. The second largest is 101.3. There's also here in the second smallest, a similar thing. And so I can find the second smallest. I will sometimes use that if I am deciding, like, if I gave students a lot of quizzes or something like that, then I might decide to drop the 2 lowest quizzes or something. Then I might want the second lowest. The kurtosis is just in Excel KURT. It doesn't matter whether it's all caps or mixed caps. Excel doesn't care. And the kurtosis is a measure of the sort of the how the distribution compares to like a bell curve, to a Gaussian curve, to that normal distribution. And so Excel's definition of kurtosis is defined such that you will get a 0 for a sort of perfectly normal distribution. And then this is a measure of how does the distribution fall off from the center? Does it fall off sort of faster than a normal distribution or slower than a normal distribution? So that's what kurtosis measures. In Excel, you have a thing called skew, formula named skew, and this is for you have these measures of centrality, and then it sort of is the distribution as it goes from the center off to the tails. Is it sort of the same on both sides, or is it sort of tilted one way or the other? And that's what skewness measures. And again, if it's a nice, perfectly normal distribution, the skewness by Excel's definition would be 0. Now, that's the usual definition of skewness, whereas kurtosis has like variable definitions depending on where you look, but Excel's definition is designed to be 0 for the normal distribution. Now, the interquartile range is just the difference between this first and third quartiles. So the first quartile is this point where if you put all of the temperatures in order, then the first quartile would be, you would have moved in orders through sort of a quarter and have 3/4 left to go. The median is where you've gone, again, with them sorted, with them ordered, gone through half of them. And the third quartile is where you've gone through 75% and still have 25% remaining. So between the first quartile and third quartile lie, by definition, sort of half the points. And the interquartile range is the stretch of temperatures in which half the data can be found. So this is not that kind of formula at all, but I'm going to take the third quartile and subtract the first quartile. And that is so in a range of 1.9 degrees around the median, we will find half of all of these temperatures. And then we use that to define outliers. So if I take the third quartile, the bigger quartile, and I add it's 1.5 times this interquartile, this is going up. This is if any temperatures are above this, they would be considered an outlier. Well, I know my max is 101.7, so I don't have any outliers on the high end. And now let's do the same thing on the low. So let's go to the first quartile here and subtract this time 1.5 times the interquartile. And this gives me the outlier. So again, where the outliers, the interquartile range tells me that range of temperatures, then half the temperatures are in. And then outliers are sort of fairly standardly defined to be 1.5. So I take D7 was my third quartile. I add to my third quartile another 1.5 times the interquartile range. And that gives me a bound that if any points are above that, they're considered outliers. And then I also do D6, the first quartile, and subtract that 1.5. And anything below that would be considered an outlier. And you can have outliers on either side. In this data, I don't happen to have outliers on either side. I said I wanted to make a histogram. So I'm going to highlight the data. Now, there are ways to make your own histogram. A histogram is going to sort of put the data in bins and display the data, sort of group the data into bins and display those bins. So I've highlighted the data, and I'm going to say insert, and I want, here are the statistical charts. It says the histogram is a statistical chart. It's going to look an awful lot like a bar chart, but it's not the same. So here is the histogram I want. And I'll just change this title, say, for temperatures. And this tells this axis up here, if you understand, so I can just call it, I don't know, temperature histogram or something. So if your viewer of the graph understands that it is a histogram, then it's understood that this y-axis is a count, a frequency, a number of times that something occurs. And then Excel has divvied the temperatures up into these bins and sort of counted how many times we got temperatures in that range, in the bin range. Now, if we right-click down here and choose to format the axis, then there are some things that Excel gives us control over. Right now, there are a number of bins. We can control how wide these bins are. So I can say I want them to be half a degree. And then it will figure out the range of bins based on that. Or I can say I want 8 bins. So that's the kind of control I have over this histogram. So that's I highlighted the data. I chose to insert a statistical graph, made a histogram, and I can control how many bins, or I can control the number of bins. Now I can, when I control like the width of a bin, it sort of determines for itself where to start. But I can do my own counting, and then I can have more control than this, but that takes more work. So we're just sort of talking today about the sort of things that Excel gives us relatively easily. And so that is a histogram. It shows us this. So these are individual measures of where's the center and how widely distributed are the temperatures. And then here's just a visual picture of these bins, or how many temperatures are in this range. So it's another way of looking at it. Another common statistical graph. So again, let me highlight the data. Another common statistical graph, insert statistical graphs, is the box and whisker. And sometimes it's useful when you're comparing one distribution to another, but it also gives you a number of these measures all collapse into one sort of a visual picture. So this top here is the maximum, unless there were outliers. And if there were outliers, they'd be like little circles up above here. But since our maximum was not an outlier, that this thin line up here represents our maximum. And similarly, this down here represents our minimum. If there were low outliers, they would be little circles floating down here below. So that's the whisker part. And then the box goes from our first quartile on the bottom to our third quartile on the top. And then the line through this middle is the median, and then the X is the mean. So it's showing us a number of statistical measures in this nice little visual package once you get used to looking at it. The min, the max, the first quartile, the third quartile, the median, the mean, And then when it really comes into its own is if you're putting on the same graph different box and whiskers to compare them. Like, is there an overlap between the two distributions, or are they pretty separated or something like that? But this is just for one, but it does grab for us quite a number of these measures and puts them together. So it gives a good picture of the distribution. And finally, I want to show, I think there's a statistical add-on. So I want to show file. I'm on a Windows machine with a local version of Excel, so I'm not up in the cloud or anything. But I went to File, Options. This is different on a Mac, but you're going to Add-ins, and I want the Analysis Tool Pack, which it's already up here. I think I already have it, have chosen it. But if it, so it's already active, but it would be down here if it were inactive. But let me sort of go through the steps anyway. So I would go here. There's another tool pack. VBA is for some like Visual Basic sort of, you can do more by programming, but I don't want to do that. I just want to see sort of what comes for free. So the analysis tool pack. Bringing these in can be a little bit funky, so you got to be careful. You don't say okay right away, you say go. And then it gives you another sort of list of them. You can see mine's already checked, but then this is the okay you want. Okay, and if you've done that, then there is under data, this data analysis. So I can click on the data analysis and I can say, I want various, I can ask for histogram for analysis. Descriptive statistics is sort of a bunch of what we've just done, sort of all grouped together. So I can say descriptive statistics, okay. And then I can say, what's my range? So I think it was A2 colon A201. I think I had 200. And I'm just grouping them all by the column, and it's just going to put all the results on a new worksheet. And I can just say, okay. Oh, please choose at least one option, summary statistics. There we go. Okay. And then this just sort of automatically gave me, without me doing all those individual functions. Now, it's useful to know the individual functions in case you want to do something further with it. Like when I wanted to find the upper and lower outlier bound, that was based on the IQR, which was based on the first and third quartile. This gave me the mean, the standard error, which I didn't calculate over there in as an individual formula, the mean, the median. I didn't do the mode, but it's there, the standard deviation, the sample variance, kurtosis, skewness, range, minimum, maximum, sum, count. So I sort of just, and there were other options I could have chosen. With that add-in, I just did the quick summary. So that's what I wanted to show you, just a lot of statistic things in Excel, a bunch of individual formulas, or some summary, some visuals, and just all these calculations, almost all these calculations are quite tedious if you didn't have Excel to do them for you. So let's just appreciate what Excel does for us. All right, thank you for your attention.